I'm Ryan Salazar, and today we're talking about encoding at scale with NetInt. Today, our first guest is Bob Fung, Director of Product Management at NetInt. How you doing, Bob?
I'm good, Ryan. How are you?
Doing great. So tell me about yourself real quick and what you do at NetInt.
I'm the Director of Product Marketing at NetInt Technologies. I'm based in Toronto, Canada. And essentially what I do is all of the sort of external marketing and product management type of activities at NetInt. Been there about a year. I've been within this industry for several other years doing a variety of things, but right now my focus is product management at NetInt Technologies.
All right, our next guest is John Plasterer, Principal Architect, Engineer and Chief Architect at NetInt. How you doing, John?
Great, how are you?
Doing excellent. So, tell us about your role at NetInt.
Well, I'm the principal engineer and chief architect here at NetInt, and I've been with the company since nearly the beginning, and I work largely on the hardware side, architecting the hardware implementation of our video encoding and storage products.
Wonderful. All right, Daniel Zhu, software architect at NetInt. How you doing, sir?
Doing great.
Excellent. It's great to have you. So tell me about yourself.
Yeah, I'm a software architect and responsible for firmware and software development of NetInt, and worked on the video products as well as the storage products of NetInt, and also joined NetInt from the very beginning.
All right. Then lastly, we have Stephen Zhu, software engineer at NetInt. How you doing, Stephen?
Hey, I'm doing good. I'm a software engineer and had been here for almost the full lifetime of the latest video product, and I do a lot of frontline and low-level engineering tasks.
All right. All right. So, Bob, I'd like to start with you first, if that's all right. So let's
Sure.
talk about what NetInt does and who you are in the industry.
Okay, great question. So, our emphasis really is on streaming video. So essentially what we do is we develop computational, or let's try that again. We develop streaming video encoding solutions that leverage computational storage technology. And we largely serve the sort of typical kind of content distribution providers in the industry. So those kind of people who do streaming video content are really kind of the different people that we serve. One of the things that we do a little bit differently compared to some other encoding technology providers in the industry is that we have designed and developed our own application-specific integrated circuit technology. So we design and develop our own Asic, which is kind of a different sort of approach than typically most encoding technology providers do today, who use things like Fpga software or GPU technologies. We do it in our own Asic, which offers a number of different advantages, which I'm sure we'll discuss later on.
Excellent. Well, that's certainly exciting. And in the world the way it is today, people needing to distribute video more than ever before in our lifetime, maybe even more than in the future right now, you guys are certainly playing a huge role in getting that video out there. So what trends are we seeing in the industry today?
Well, great question. If we kind of take just sort of a step back and look at how things were sort of beyond or before the current sort of global events that are unfolding, I think one of the things that we see in the in the greater sort of video industry is this unprecedented growth in streaming video. There's various industry projections today that really see in the next 1 to 2 years that streaming internet video will be the primary type of traffic on the internet. These are things like streaming television, like OTT, IPTV. There's other things too, like like gaming and AR and VR type of video services that are really driving this unprecedented growth in streaming internet video. So that's kind of basically what we're seeing now is streaming video is just growing like gangbusters.
All right, so I'm really curious. So your role in the world of streaming, and you just had that graph up on the screen. It mentioned OTT and other types of streaming formats. Are you utilized in a specific space? Or are you kind of in that whole spectrum?
We kind of, our sort of primary uh, space that where we kind of started was this, the OTT sort of IPTV sort of marketplace. But just with the with the overall growth of streaming video, there are so many different content distributors looking for new leading edge types of encoding technology that we've really expanded our reach into these other areas. So basically, we in a nutshell, we sort of play in all these different spaces.
All right, so what are the biggest challenges facing us today?
You know, the biggest challenge that's facing the streaming industry or sort of the greater industry at large is really the same type of challenges that face us as individual people today. We're right now in the midst of a terrible global pandemic, COVID-19, and what that's done is really fundamentally changed how we do so many things in our life. And our industry has not been, untouched by that. And essentially what we're seeing now is with people trying to do things differently, that we're seeing, accelerated growth in so many different new services for streaming video. So uh, as an example, that would be something we could look at something like distance learning or e-learning, right? Where this was obviously kind of a going concern, before the pandemic. Now it's something of critical importance to us. Also, other types of applications like surveillance. Obviously, we need to sort of keep an eye on what's going on in the world, is also becoming more of a concern. So there's all of these new different applications. In addition, if you look at some of the existing applications like OTT and IPTV, uh, obviously lots of people now spending a lot more time at home looking for things to do. So they're at home now watching television. And obviously, this is also placing a lot of demand on these existing services. So one of the big challenges that we see today in the industry is all of these new services, as well as existing services like OTT and IPTV content distributors, scrambling now to make sure that they have an infrastructure that can meet this new unprecedented demand that was driven by existing market trends, as well as the current sort of pandemic crisis.
All right, so Stephen, I'm curious, how will this global pandemic change streaming video in the short and long term? And I'm curious what it means to you on the software development side, of course.
Well, I think in the short term, we're already seeing that that everyone's staying at home and has really driven up demand for entertainment that they can use at home. So we're seeing stuff like Netflix and YouTube cutting their default resolutions so that they can better service all the demand through the bandwidth that they have. And in the short term, it's driven by yeah, people staying or the new social norms that this pandemic has caused. But I think in the medium and long term, we're going to see more of a change in consumer trends that's going to occur. So probably so after this pandemic is over, people are more free to do other leisure activities. Some of them may still be sticking with some of the Netflix shows that they might have been watching during the pandemic, and get used to habits such as that. But I think also we're going to see some new fields that are starting to emerge, like as Bob alluded earlier, and distance learning. I could see like the local university in town. They're moving from lectures in halls to lectures online, and this is a new sort of paradigm for streaming as well. So instead of having your web conference feed go out long distance across the continent, you could just be streaming from a source in town to students also in town, and this is really something that we believe is a very succinct edge application.
Yeah, when we first built our facility here in Fort Lauderdale, Florida, it was all based on streaming and whatnot. It is built like a real TV station, but we have the ability, obviously, to do live streaming and whatnot. But we never realized, this current situation and the time that we're in now, to have the ability, we're positioned in a really amazing way to facilitate the things that we're seeing and other folks doing. And I will say, obviously, the streaming world is evolving at a really rapid pace right now, especially over the last few months. I cut the cord recently at home, and I'm literally using YouTube TV, Fubo TV, and those other types of platforms. And I think that this means so much for you guys as a company, because the development side of things and the potential, the possibilities for you and your clients are just endless. Bob, I'm curious what you think about that.
Yeah, I mean, this is, it obviously is the circumstances now are really obviously unfortunate that we're all in this situation, but it's also a massive opportunity for the streaming industry to essentially uh, reinvent itself and to meet the demands of people now. That there is a lot of pressure on us as an industry, as us as people who provide solutions, and to the content distributors to create solutions to really help people now. Like, that's something I think that all of us today, when we go to work, that we think about that there is a real world urgency to what it is that we're doing right now. And I think one of the big challenges that we as an entire sort of streaming industry face right now is scalability, our ability to ramp up very quickly to meet these new challenges and these new demands for streaming videos and in all of these different services. I don't think 2 months ago that we imagined that we would be in this place today, where we have such an incredible demand for streaming content that we have to cut back resolution in places like Europe for Netflix. So our work is cut out for us. Really, what as an industry, some of the things that we need right now are the ability to scale and to ramp up very quickly. Obviously, a lot of streaming video today, all of it, comes from things like big streaming video data centers. You don't overnight create. You can't overnight create like a bigger data center. You have to think. We have to be smart about this and think of creative ways to ramp up our streaming capacity. I think almost literally overnight now. So our work is definitely cut out for us.
All right, so there's lots of talk about the edge. How does this fit, let's redo that. So there's lots of talk about the edge. How does this, so there's lots of talk about the edge. How does NetInt fit into this discussion, Daniel?
Yeah, there are many highly interactive video applications, such as cloud gaming, AR or VR applications, vehicle-to-vehicle, vehicle-to-infrastructure, self-driving applications. These have very stringent latency requirements. To enable this kind of applications, doing transcoding on the edge is also a must. There is an example, for instance, the typical end-to-end latency for cloud AR or VR gaming is around 20 milliseconds. And this includes the rendering time, the video encoding time, and network delay. So, really, the video encoding has to be happening on the edge, and it has to be very fast. NetInt, together with Tiri's.
Oh, go ahead. Pick it up.
Yeah, so NetInt, together with Tiri's research, has just published a white paper on cloud gaming. We have a Asic-based low latency video encoding solution that perfectly fits into the cloud gaming requirements.
Excellent. All right, I'm going to toss it to John now. What do you think, John?
Well, one thing I think is that the current architecture of the CDN transcoding is really on a central, infrastructure. So most of the encoding happens at a central server, and unfortunately, what that means is that for certain applications, that's not quite as efficient. For example, events that are growing in popularity right now, and particularly in this environment, we're seeing schools, sporting events, parties. these sort of applications are limited to a much smaller locality, right? So you may see that your particular county or your particular city may have most of the endpoints for that, and in which case, encoding on the edge is much more efficient. However, in order to implement that, a hardware implementation needs to be a lot more efficient in order to be economical to spread those solutions out to the edge nodes.
All right, so to that end, what applications need to use the edge, Daniel?
So as just said that there are many highly interactive video applications, those cloud gaming, AR, VR applications, self-driving cars, those kind of applications will need this edge computation. Especially in the age of 5G, this becomes more and more obvious. So the network bandwidth, the theoretical network bandwidth of 5G is 100 times of that of 4G. So with 5G, the last mile bandwidth becomes abundant. And we can expect that a lot of HD or UHD videos, such as surveillance video, user-generated content video, and also so for the self-driving cars, a lot of video has to transfer to the infrastructure. Those kind of videos becomes more and more. And if you route all this traffic to the core network could be easily overwhelmed and becomes a bottleneck in these applications. So to really avoid that, it's really necessary to do a lot of video computations on the edge. This include the video decoding, video analytics, video processing, video transcoding, etc. So NetInt actually has a ASIC-based video decoding and encoding solution. It has lower power consumption and very low cost. It suits very well with the edge video computation requirements as well.
All right, so one more question for you. So how will 5G help enable the edge? And 5G is certainly all the talk recently.
Oh yeah, so as I just said that the 5G is the bandwidth is 100 times that of 4G. So with 5G, you will see more and more video of high definition with high bandwidth requirements. And so you really want to terminate the video computation at the edge instead of crowding your core network with a lot of high definition video traffic. So that means that to enable the video computation at the edge, you have to do the video decoding. And then when it's decoded, then you do video analytics. Then only send the most interesting video to the cloud for more advanced video analytics or for video the AI model training. So that's the key. So then to enable that, really you need a very high efficiency video encoding, decoding kind of solutions. So that's where NetInt comes into play.
All right, so John, the explosive growth of streaming video is going to, So John, the explosive growth of video streaming is going to require content distributors certainly to upgrade their encoding capacity. So let's talk about the challenges that they face.
Well, we've sort of already touched on this a little bit, but the server infrastructure required for the deployment of software-based solutions starts becoming very, very unwieldy, both, when we start going to the scale that we need to deploy for a lot of these different applications, as well as when we start pushing towards what we need to hit as we scale up is these more efficient codecs like H.265. So really the only solution that really makes sense for these providers, these CDNs or other types of application providers, is a hardware accelerated solutions. And they could look at ASICs, FPGAs, or GPUs deployments. Allows for a much smaller server footprint to reduce power, reduce the CPU and overall cost of the infrastructure.
All right, so why would I pick ASIC over FPGA or even GPU?
Well, the answer is pretty clear for ASICs, and I'll tell you why. FPGAs, as you probably know, are really high-powered and very expensive, and they're really not optimized. The main situation where you'd want to look at an FPGA is maybe you're dealing with a new codec that hasn't had the opportunity to have a more optimized ASIC solution. GPUs can be tempting because, as we know, there's many, many GPUs out there, and GPUs do have some encoding and decoding capability in there. But if you look at the encoding and decoding quality of these solutions, sometimes may not be where you want it to be. As well, there's a lot of overhead when it comes to a GPU, both in terms of the size of the product for how much streaming capacity you get, as well as the overall power solution. So you might find that a GPU solution may have power in the order of, 75 watts per unit, which may do, a certain number of streams. That's just the GPU by itself. You have the overhead of the server, whereas an ASIC solution might be 5 or 6 watts to get the same amount of performance. So clearly, the ASIC is the more optimal solution, and that's why you would pick that one. You may look at the other ones depending on your application, but if you can find an ASIC that suits your needs, then that's the best solution to go for.
All right, so Bob, the encoding architecture for these new video services, what's really different from a conventional system?
Well, I could touch on a couple of them. So, obviously, I've talked a bit at length about some of the other existing kind of streaming video services like the OTT and the IPT type of services. If you look at some of the new emerging type of services, some of them which will, leverage 5G. I think Daniel talked about this. I mean, for example, if you look at something like cloud-based mobile gaming, where essentially what we want to do is take games that have typically been played on mobile platforms like smartphones and tablets, and then stream those through a cloud-based infrastructure. The kind of things that are important in order to effectively do this are a little bit different than some other types of video services. So, for instance, in the case of cloud mobile gaming, I think the first major consideration is scale. So if you look at the entire gaming market, that's a $150 billion industry, I think, and I think mobile gaming itself is about a $45 billion industry, and cloud mobile gaming will probably take a portion of that share. So the first thing to think about is scale. So a lot of these new emerging type of services like cloud mobile gaming, the scale of these are just massive. So from the beginning, when planning out these types of infrastructure, it is important to think about how am I going to scale this up. You're not just going to build a cloud mobile gaming infrastructure and then leave it alone. You got to be able to plan for sort of explosive growth, which is kind of a theme in streaming video that we've been talking about for the last for this webinar. Is an important consideration is scalability. Now, also with cloud mobile gaming, another sort of big friction point is latency. So in order to have a really immersive, fun kind of gaming experience, you got to be able to manage your latency. So I think typically in a gaming type environment, you probably want less than 70 milliseconds, which I think is about 2 frames of video of latency. Once you start exceeding that, the quality of the experience diminishes quickly. And then when you look at other types of mobile gaming technologies like VR headsets, the latency threshold is even lower, probably around 20 milliseconds. When you start getting higher than that, you start getting into things like motion sickness. So it isn't important in planning these types of infrastructures that you do pay very close attention to latency. And as I think Daniel previously talked about, one of the considerations for doing this is really looking at deploying an edge-based infrastructure as opposed to maybe doing a sort of a more centralized data center architecture. Now, another application, and this is more in tune, I guess, to the current pandemic, some of the other new applications that we're seeing is that now what we're seeing is streaming video content distributors have some new requirements. And one of these that we've very interesting that we came up with was that we've heard about is what I'm going to call sort of emergency alert messages or public service messages. So this is typically something I think in the past we've mostly seen on things like cable or over-the-air broadcast, where you would have emergency public service announcements. But now, with the current crisis, what we're seeing is the need and the requirement by content distributors to be able to have these type of emergency messages over streaming video content. So not just sort of over-the-air live television, but actual, streaming content. So today, a lot of content distributors are not equipped to do that, certainly at scale. So now that's sort of a new emerging requirement that we're seeing now, and something that as we sort of work our way through this pandemic, that we have to start implementing.
All right, Daniel, anything you'd like to input on that?
Yeah, I just want to point out the our ASIC-based hardware encoding or decoding solutions. This kind of solution can enable, many new kind of architecture or new implementations for the older use cases. So one of these typical use cases that the live streaming I talked about earlier, it actually with the lower cost of hardware encoding, we can do more transcoding for even long tail contents. And another use case is that in the social media, any minute many people are uploading the video, so you really want to do a quick transcoding to publish this video very fast. So that's where the hardware encoding comes into play as well. And also in the cloud business, there are people renting out the transcoding as a service. So if you have a whole bunch of high density video transcoding services in the cloud, you can rent them out. So that's where the hardware encoding also play a big role. And traditionally in those OTT services, which usually use some proprietary hardware to do the transcoding, now they can actually adopt our solution to use software decoding for the legacy codec and use the H.265 and the very high quality hardware encoding with our solution. So that's how our hardware, encoding can enable some of the older use cases.
So Stephen, I hear you have a video for us.
Yes, so NetInt provides a ASIC solution for an ASIC product, and it can interface with a lot of low-level programs like FFmpeg. But we're also working with our partners to build a GUI system that's more familiar for broadcast and OTT customers to transcode streams statically and be able to monitor it all through a web interface. And here I will show our web interface for it. So this web page is a control interface for an integrated transcoding product that our partners at Torque Video have been working on. It's a system with a quad-core CPU and just one T48, but look at how many streams it's capable of processing. Right now it's transcoding 6 1080p inputs to 12 encoded outputs of varying resolutions, bit rates, and codecs, and the T48 is still not even maxed out yet. I can add even more transcoding streams just by going into the GUI, selecting the input network port, and let's say the output to be targeted to my workstation at 2 megabytes 720p HEVC, and I can just start it and view it on the network. So I think this GUI would be really useful, say, for OTT and broadcast customers that want to set up and monitor streams that run for long periods of time. But it also really goes to show the scaling power of ASICs. This is with just only one U.2 card. Now imagine going to a 1U server and having 10 to 12 T48s in it. You can transcode 10 to 12 times as much streams as what we have here, and this is already 7 streams. That would be unthinkable with just software-based transcoding. So as you can see with this demo, it's can run a lot of channels through one encoder that previously wouldn't have been possible on a CPU encoding server with 7 streams and 12 to 14 outputs. This is really something that's going to be a game changer, I believe.
All right, thank you so much. Thank you, everybody. Bob Fung, John Plasterer, Daniel Zhu, and Stephen Zhu. I really appreciate you being with us. And on our way out of this interview right now, or this webinar, we're going to play a video from NetIn. And here we go.